Buzz duct accessories, fire separation walls and fire stops. Introduction. Fire accidents are a major cause for concern as it has a devastating consequence to life and property. The root cause for the origination of fire could be many. Any electrical equipment that is not designed and protected adequately for the purpose or is abused can be the root cause for a fire. This discussion is limited to containing the fire and preventing it from spreading to the designated areas. Fire separation walls and fire stops. Metal enclosed air insulated bus, as with any other duct such as a ventilation duct, can aid in the propagation of smoke and fire from one location to another. The propagation is faster when the configuration is vertical, aided by the chimney effect. There have been instances when the smoke from the fire-on generator transformer, traveling to the generator terminals through the isolated phase bus, have initiated fire and damaged the generator. Whenever an enclosed bus crosses a wall that separates two ambient areas, an opening is provided on the wall for the crossing. It is recommended that the opening and embedment, if any, be designed in consultation with the manufacturer of the enclosed bus. The manufacturer of the enclosed bus will supply a wall frame assembly to suit the opening and embedment, with the necessary components, to meet the specification requirements. Many terminologies on this subject are loosely used in the industry. It is, therefore, important to have a clear understanding of these. Fire separation walls. These are walls that are installed to separate the building from vulnerable equipment. A wall separating the transformer from the building falls under this category. It is a practice to install a fire partition wall close to a generator transformer and building and between the single-phase generator transformers of a delta-connected system. These are concrete walls that are expected to contain an explosion within a confined area. Fire stops. An opening with embedment is provided by the project authorities, on the wall, for entry of enclosed bus. The size of the opening shall be, as suggested by the manufacturer of the enclosed bus, and kept to a minimum. To prevent the propagation of fire, two separate areas must be sealed. Fire partition between bus duct enclosure and wall opening. The composition of this material is inexpensive. It is a cement-based formulation that is quick-setting and water-resistant. Its application at the site is also simple. Fire partition between conductor and enclosure. This process of preparation of fire stop inside the metal enclosed air-insulated bus enclosure is very critical. The preparation of the conductor insulation at this location is very important. The conductor shall be fully insulated for the specified thermal class, basic insulation level, and creepage distance. Two insulating plates are installed at predetermined locations and foam is filled in the annular spaces. The thickness of the foam is recommended by the manufacturer, based on the specified hour rating of the fire stop. After the foam is set, it is sliced to shape and the enclosure cover, installed. It is necessary to understand the requirements and suitability of a fire stop. It is used when an enclosed bus crosses from one ambient or classified zone to another. It may be specified when an enclosed bus crosses a wall separating the indoor and outdoor areas. It may be specified when an enclosed bus crosses a wall separating hazardous zones. The fire stop must have compatibility with the wall on which it is installed. It cannot have a rating higher than that of the wall. Specific to an enclosed bus, it has to perform the following functions. Prevent the spread of flame or smoke, as per the specific requirements. Ensure that the performance of an enclosed bus is not compromised by the introduction of the fire stop. It is understood that in the event of a fire in one of the areas, the enclosed bus may get damaged beyond recognition along with the fire stop, but it must ensure that the effect of fire is not felt on the other side of the fire stop. In the event of a fire accident in the vicinity of the enclosed bus, where the bus enclosure seems to have been visually subjected to its effect, the entire enclosed bus must be cleaned and a thorough examination conducted before it is put back into operation after routine tests are performed. Classification of fire stop. It is necessary to understand various classifications and the contexts in which they are used. ASTM 814/UL1479 defines the function and the method for assigning the rating to a fire stop. Fire stops are physical barriers, designed to prevent the spread of flame or smoke. Depending upon the function, they are classified under F for flame, T for temperature, L for smoke, and W for water tightness. Rating. The letters stand for their withstand capabilities for flame, temperature, smoke, and water tightness. Rating F is expressed in hours. It is an indication of the period of time, A barrier can withstand the fire before being destroyed or allowing the flame to pass through the opening created by it. Rating T is expressed in hours. This indicates the period of time the surface which is not exposed to fire does not record a temperature rise of 320 degrees Fahrenheit or 162 degrees Celsius above the ambient temperature. This ensures that any material on the side of the surface that is not exposed to fire does not reach the flash point, resulting in further propagation of fire. Rating L is measured in cubic feet per minute. It is a volumetric rate of hot air or smoke that can force its way through the barrier in cubic feet per minute. The test is carried out at the ambient temperature and at 400 degrees Fahrenheit or 204.5 degrees Celsius to evaluate the performance of the fire barrier at different temperatures. These barriers are tested with a differential pressure of 0.3 inches of water column or 75 Pascal at 75 degrees Fahrenheit or 23.6 degrees Celsius and 400 degrees Fahrenheit or 204 degrees Celsius. Rating W indicates the fulfillment of water tightness requirements as per tests specified by the underwriter's laboratory. This rating, introduced in 2004, classified the barrier under 3 categories. Class 1 requires the material to be subjected to 3 foot or 0.915 meters of water column for 72 hours, followed by a fire and hose stream test detailed in ANSI/UL 1479. Class 2 and Class 3 require the material to be resistant to 20 foot or 6.1 meters and 57.54 foot or 17.54 meters of water column respectively. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.